A local variable is declared within the scope, and then we'll call it a module level variable, which is loosely known as a global variable, but that's very loose. Module level variable is declared in the general declarations section of a module outside of any sub-procedure. It is known by name anywhere within this module and can be accessed by anybody in the module. It is born when we declare it. It's alive as long as the module is in memory. So it's born when declared, alive while module is in memory, dies when module leaves memory. All right, let's look at our other questions. I think these will be a lot quicker because we kind of know how it works now. What is int counter after the first line? It is 1. What is int counter the first time it gets to here? It is 3. What happens on this line? Int counter becomes 4, so what gets printed? 4. What does the next statement do to it? Makes it become what? It was 4. It kicks it up to 6. 6 is still between 3 and 7, so it goes into the loop. What happens to it here? Becomes 7, so what gets printed? 7. Then what happens to it? It becomes 9, not in range, out of the loop. So it should print a 3 and a 7. Sorry, 4 and 7. You're right. Yeah. We incremented it before we printed. You can see that the order in which you code it makes a big difference, right? If we had put this, if we incremented it afterwards, it would have printed a 3 and then a 6. But because we incremented it before we printed, it prints a 4 and a 7. So let's just verify that. This will be a new sub called test Q3. What'd we say, 4 and 7? Well, let's stop it before it leaves. Oh, we did not compile and we did not declare that variable. It was declared in the other subs, but this is a new sub. And we have option explicit at the top, don't we? So it would be nice to dim that thing. Now I'll bet it will compile. All right, so let's run this. 4 and 7 are indeed what are printed. Int counter is still alive because we haven't exited the sub yet. And it is 9, just like we thought. And now we exit the sub and int counter is dead. Okay, let's look at number 4. That's the infinite loop, isn't it? We will not run this, but if the question were, is there a compile error? If so, how would you fix it? Is it yes or no compile error? This will compile fine, won't it? It says, hey, that's a legitimate do-while statement. That's a legitimate statement. That's a legitimate way to end it. I don't guarantee what's going to happen, but you said those things just fine. So this would be compiles. Is there a runtime error? Yes. What will be the output? Infinite loop. It will print 2 over and over again until it fries the memory and crashes. So how would we fix that runtime error? We would increment the counter within the loop. So let's not run number 4, but we will run number 5. Int counter is 2 What's int counter right here in the first statement of the do while loop? It's still 2, isn't it? We haven't done anything to change it. In a for next loop, the for statement actually assigns the start value to the variable. All right, so int counter is 2, so what gets printed? 2, then it becomes 3, still less than 7, prints, 4 prints, 5 prints, 6 prints. When it turns into 7, what happens? It's not less than 7, so it exits the loop. So this should print 2, 3, 4, 5, 6. Is that what we think? 2 through 6 by step of 1. So this is sub test Q5. And I will not make the same mistake of not dimming my variable. And it never likes that automatic bullet thing. Be sure to use proper indentation when you do your code. Notice that sub and end sub are on the margin. Every other statement is indented, and then within structures, all the statements between the beginning and the end of a particular structure are indented further. So we can see easily here's where the loop begins and ends. If we run this, we're thinking we would get 2 through 6 and that int counter would be 7 when it finishes. There's 2 through 6, int counter is 7 when it finishes. Give yourself a gold star if you predicted that correctly. Yeah, I do think knowing what's in int counter when it exits the loop is critical as well, because we always want to know what's going on in memory. All right, number 6 says int counter starts out as 2. Does it enter the loop?
What do you mean, does it enter?
I mean, will it run the loop at least once?
Oh.
Yes, because 2 is less than 7. What happens to it here? It becomes what? It becomes 4. So what gets printed? 4. Now we come up here. It's still 4, isn't it? So we go in the loop. It becomes 6. It prints 6. We go up here. It's still less than 7. We go in the loop. It becomes 8, and it prints 8. And now when it comes up here, it says that's not less than 7. Runs out of loop. So what's int counter when the loop ends? It's still 8. Okay, so this should print 4, 6, 8, and int counter should be 8 when it ends. So this is question 6. What do we say? 4, 6, and 8, and it's 8 when it ends? 4, 6, and 8, and it's 8 when it ends? Very good, class.